Hello guys, welcome back to our channel. Hope you are good. So last time I had promised to start discussing hypothesis 1 in statistics, but as I was going through the comments, majority of you are suggesting that we start discussing a statistical software to have some skills in analysis using these softwares, so that when we discuss test of hypothesis, at least we have some basics in one or two of these softwares. And I considered that. So today I'm here to introduce to you statistical computing using R programming. R is a free software. If you don't have R in your PC, you can just go to your browser, download the software, and we start the session together. So, like I said, we have R software and we also have R Studio. R Studio is just an advancement of the R software that tries to make it simpler when it comes to writing the instructions or the codes. So in this session we will use the R software, and in some other sessions we will use the R Studio, such that at the end of the day we are familiar with both the R Studio and the R software. Even though the syntax and the commands remain the same, there is a little bit difference in the two. So this is the R software. You can see once I open the R software, there is this console window that opens. In this console window, it is the window where we will be typing the commands or the instructions. And basically we are saying a code or a command is a set of instructions that carries a certain task or does a certain task. So in this tutorial, I'm going to introduce R by discussing some fundamentals in R programming. That is the basics in R programming. So we are going to discuss about variables in R. We will discuss how we can declare variables in R and how we can use them to carry out some computation, and also see what is the importance of using these variables. We also will also discuss on how to create vectors and matrices in R, and also perform some operations involving vectors and matrices in R. So the R console, that is the R console, where we'll be typing our instructions or commands. Realize when we plot a graph, when we plot any diagram, let's say we have a pie chart, a histogram and such, another window will open, that will print the output. In the next session, where we'll be discussing statistical graphs and such, we'll be able to see that. But basically, this is the windows in R, or the console in R, that will be typing our inputs, and will also be obtaining our output on this console. So suppose I want to add two values or two numbers, let's say 6 and 9. I can basically go ahead and type 6 plus 9, and you realize when I click enter here, the answer is 15, and it is well known that 6 plus 9 is actually 15. So you realize another way of doing it is that we can assign the value 6 to a variable, let's say x. By the way, a variable is a memory location that is used to store data which can be later used. It is a memory location that stores a data. So I can say I have I have a variable x, and that variable x is going to store the value 6. That is what we call the variable declaration. When I say x to be my variable, I'm trying to tell the software that I'll be using x as my variable. And when I say x is equals to x to 6, I'm basically assigning a value to that variable x, such that when I call the variable x, x will be 6. And I can assign the variable y to the value 9, such that when I call 9, y, I'll be having 9. So I can go ahead and add x and y to get 15. As you can see, x plus y is 15. It is just the same like using 6 plus 9, we are getting 15. But now in this case, we are using variables, a memory location that stores data. In this case, my variable x is storing 6 and my variable y is storing 9. So when I take x plus y, I'm getting 15. Again, suppose I want to use the sum of the two numbers 6 and 9, which is as good as the sum of x and y. Somewhere else, you realize I can also assign a variable to the sum of x and y. Let's say a variable z. So I can go ahead and say z is equals to x plus y. So when I call z, z equals to 15. So the variable z is a memory location that is storing the sum of the two variables x and y, which is as good as saying the variable z is a memory location that stores the sum of 6 and 9. Why use variable? What is the importance of using variable? Realize one of the importance of using variables is very clear, that we can use the variable anytime, at any given time. Suppose now I want to use the sum of 6 and 9 is now to be divided by 3. I won't take 6 plus 9 again, then divide by 3. No, I'll just take z, divide by 3. Why? Because z is storing the sum of the two variables. So basically it is easy to do some computation using variable because we can access the variables at any given time. But if we don't use variable and we use the actual values, so therefore it means that at any given time we will have to type the variables or the values afresh. So that is all about variables, a memory location that stores data. You declare and assign variable, you declare and assign a value to a variable. So my x is equals to 6 is the variable x assigned the value 6. My y is equals to 9 is the variable y assigned to value 9. Z is the variable that is assigned to the sum of x plus y, which is as good as saying z is the variable that is assigned to the sum of 6 and 9. Hope you guys are getting it clear. Now, let's go to vectors. Realize, suppose we have a vector and that vector comprehenses of, let's say, 4 elements. And we want to declare that vector here and say I have a vector v which has 5 elements or 4 elements, and these elements are 2, 6, 4, and 3. And that how am I going to create such a vector? Realize, because the vector will have more than one variable, we will be using the concatenating function. We'll be using a concatenating function. And basically, in programming, mind you, R is it was developed from S programming, so it's actually a programming language. So in programming, a function is a set of instructions that or sets of instructions that carry out a specific task. So here, a concatenating function is that function which will store the values of a given vector, or rather will store collectively the values of a given set. So I have my vector v, the concatenating function. So like I'm saying, suppose we have our vector v, which has the elements 2, 6, 4, 3, and I need to create the vector. So here I'll be having a comment. By the way, commenting are those statements that are not executed. They basically tells us what a certain code does, such that in order for someone who is not a programmer can easily understand what is happening in such set of an instruction. So here here in R, comments always start with a asterisk, a hashtag or a hash. So I'm saying create, here I'll be creating a vector, or rather let's say vectors, how to let's say vectors in general. So I need to create a vector. I have a vector v and I want to create the vector. I'll use the concatenating operator. So my vector v will be equal to the concatenating function, not operator, actually it's the concatenating function, c, then we have the curly bracket. This is the concatenating function. Actually, I should show you the concatenating function. This is the concatenating function. Yeah, so we will be having the values in this bracket. But like I have introduced the variable, we need to assign this to a certain variable, and my variable is v, and in this case the variable is a vector v. So what are the elements? I will list all the elements in the concatenating function, in the bracket of the concatenating function, separated by a comma, except to the last element. So I'll be having 2, comma 4, comma 6, comma 3, and that is my vector. So when I say my vector v equal to, my vector v is the vector of the elements 2, 4, 6, and 3. So you realize R will always display the vectors as a row vector. As you can see, this is a row vectors. But however, R also treats column vectors as well. So it can treat column vectors, though it will display them as row vectors. So basically, that is how we can create a vector. So suppose I have a vector, let's say a vector v that is of the elements 1 to 10. So I can come and say, I can use the concatenating function and say v is equals to the concatenating function. Then in the concatenating function, I list the elements. So it is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and there is no comma to the last, so that when I say v, I'll be having these elements as the elements of the vectors v. Now you realize that if the elements of a vector are consecutive in nature, then creating such a vector becomes more simpler, because we can specify the range. That is, my vector, like for this case, my vector v is starting from 1 to 10. So these elements here are consecutive in nature, and because of that, I can simply write this vector as the vector v, or I can define this vector v as v is equals to the concatenating function, yeah, of the elements, that the elements are actually starting from 1 to 10. So this is as good as listing all the elements one by one, but because the elements are consecutive in nature, then there are more conscious ways of creating such a vector, and that is the way. Say that when I say v, when I call the vector v, I'm having the vector v, which will be the vector of the elements 1 to 10. As you can see, the two vectors are the same, but the mode of defining the vectors is different. So when the vectors are consecutive in nature, let's take note that we can simplify by just declaring and say the vectors in this way. So we realize I can also perform a logic. I can also introduce a logic variable, and we know logic variables will always tell us the truth value. So suppose I want to say that the elements in this vectors V, I want to say the truth values of the elements in this vectors V are actually less than 4. So I can come and say here V is actually less than 4. So when I click enter, you realize that the truth value will be displayed like that. Yeah, such that what is happening here is the vector V is of the elements 1, 2, 3 all the way to 10, and I'm saying the vector V is less than 4. So what is happening here basically is that we are taking every element of the vector V and compare it to the value 4. If that element is less than 4, then the truth value will be true. And if that element is greater than 4 or equal to 4, then the truth value will be false. So 1 less than 4 is true, 2 less than 4 is true, 3 less than 4 is true, 4 less than 4 is false, 5 less than 4 is false, and it continues. Again, you realize we can assign the truth value to a variable, and that is what we call the logic variable, and say y will represent will be our logic variable. So my y will be equal to the vector v being less than 4, so that when I type y, I get the same output as this one, only that here now we have defined and the logic variable y. So that is basically how we create vectors in R. You use the concatenating function to create vectors in R. Very important, the concatenating function. There are also other functions in R that we can use to do some analysis. And like I said, a function is basically a set of instruction or a block of instruction that performs a specific task. So there are many functions for statistical summary and analysis in R. Like for example, we have the function that will always compute the mean of a given vector or given set of elements. So the function that will compute the mean is actually the mean function, and it takes this form, the mean function. That is the function, and always this is the function prototype. Prototype is like the nature of the function. The function will always have the function name and the curly bracket where we will define the variable. For this case, in this curly bracket we will have the variable that we want to compute its mean. So you realize always a function will have a name and the bracket to specify the variable. So if I want to get the mean of the vector v, I'll simply come and say mean and v. V is now my parameter. V is now my variable in this case, and it will be in the bracket. So you realize the mean of V will be printed out as 5.5. You can do that simple math, add these and divide by 10, and you realize that is the answer. I also have, there's also a function that will compute the variance of a given set of values in R. So the function is var, and we have the bracket. The name of the function is var, and this curly bracket will have the variable that we actually want to find its variance. So var, for this case, because it's a matrix, it is saying that, it's a vector, it is saying that we cannot compute the variable, the variance. But as we continue, we'll be having some other cases where we'll be able to compute the variance. So, like I'm saying, we have also other functions like the function that can compute the variance of the set of elements in a given vector. So the function is var, and you will have the square, will have the bracket like that, So var is the name of the function, and in this bracket we declare our variable. So for this case is v, so we'll be having our variance of the vector v as 9.167, like that. We can also compute the sum of the vectors, the sum of the elements of the vectors, and in this case we'll use the sum function. So we have the sum function like that. This is the name of the function, and the bracket like that, where we'll be having our variable v, or our vector v, and the sum will be printed. We can find the cumulative sum. So this is the sum, the total sum of all the variables in the vector. But we can also as well compute the cumulative sum. The cumulative sum, and we have the cumulative sum function. So we want to get the cumulative sum of the elements of v in the elements of the vector v. So you realize in this case we will be having 1 here. Then we are taking this element added to this element, we'll be having 3. Then this the sum of this element added to the third element will be having 6. The sum of these 3 elements added to the fourth element, like that, and it continues. And you realize this will be the output. That is 1 plus 2 is 3. 3 plus 3 is 4. 4 is 6. Sorry, 6 plus 4 is 10. 10 plus 5 is 15, and like that. Again, we can decide to find the median of the elements of the vector v. So we will use the median function, the median of the vector v, and we will get the median of the vector v as 5.5. We can also determine the length of the vector v. What is the length of the vector v? And realize the length is basically the number of elements in the vector v. So I'll use the length function to determine the length of the vector v. So I'll use the length function, and you can see the length of the vector v is actually 10, meaning that the vector v has 10 elements. So basically, these are some of the function, and I'm saying some of the function that are used for statistical summaries and analysis in R. But there are more functions. Later on, we'll be introducing the issues to do with packages in R and all that. We shall be able to see a number of functions that carry out different operations and tasks, different computations in R. So basically, this is the introductory part about vectors. So let's continue and say, suppose we have two vectors. Say I have a vector x and I have a vector y, and I want to carry some operations. So let's say I have the vector x, which consists of 4 elements, and another vector y, which is having 4 elements. So let's start by defining our vector. So my vector x is having 4 elements, and because there are more than 1 element, actually I'll have to use the concatenating function. So that is the concatenating function. Then I list all the elements of the vector x separated by a comma, except to the last element. So the first element is 10, comma, the second element is 20, then the third element is 5, and the fourth element, let's say it's 4. But that is my vector x. Then I have my other vector y. Of course, it is having 4 elements, so I have to use the concatenating function. And this is having the elements, let's say negative 2, comma 15, comma negative 6, comma 8. This is another vector y, also having 4 elements. So suppose I want to carry a computation, or I want to evaluate a certain computation. Let's say I want to find x squared. I'm saying the vector x squared plus 2x plus x divided by y plus 3. How am I going to write that in R? And you realize it is simple because I was saying x squared, so it is x raised to 2. That is how we write it. Then plus 2 multiplied by x, that is 2x. So it will be 2 multiplied by x. And you realize multiplication here is denoted by the steric. The steric will be used to denote multiplication in R, as well as it has been always used in many programming languages. Then plus, and I'm saying x divided by y, then plus 3. And you realize because this is a computation of vectors, the result in this case will be also a vector, because we are taking this vector squared. So we are taking every element of the vector x and we square it. Then we are taking every element of the vector x and we multiply it by 2. Then we are taking the corresponding elements of x divided by the corresponding elements of y. Then the resultant vector here plus 3. So which means the resultant vector here, we will be adding 3 to each and every element. Okay, actually I forgot to tell you one thing, that R is case sensitive. That is, capital X and small x will be treated as two different objects, and that is why here it is saying object X is not found. Actually this is good because I forgot to tell you this, and you realize here I have 2 multiplied by capital X, and for this case here capital X is not defined anywhere, so this should be small x. And I repeat, R is case sensitive, and this is the answer of evaluating this. And you can confirm because here it is x squared, so we have 10 squared. Then we are taking these multiplying by 2, so it will be 100. Then this multiplied by 2, that will be 120. Then this divided by this will be -5. So 120 minus -5, 115. Then plus 3, 118. The same to the other elements, and that is the computation of vectors, and that is how we will be going to tackle such questions. Now, how do we access the elements of a given vector? Suppose we have a set of we have a vector. Let's say we have a vector y, and we want to access the elements. We just want to use a particular element, not all the elements of the vectors. That is, I have my vector y, and my vector y is having, let's say, 5 elements, and because it is having 5 elements, of course I need to use the concatenating function. So I have my vector y of the elements, let's say 40, -50, 100, 70, and 90. Let's say 90 because we already have 40 and 90, like that. So I want to use -50, or I just want to print out -50 of the vector y. You realize elements of a vectors can be referenced by giving the name of the vector followed by the subscript in a square bracket. That is, I need to have the element, the name of the vector first, and the name of the vector is y. Then in a square bracket, I need to state the position, or rather, we can say the address or the location of that element. So you realize the position of that element. You realize in this case, -50 is in the second position. So I need to have 2 in the square bracket, like that, and this will give me the second element of the vector y. Very important, because now and then we'll be using some set of so like I was saying, referencing the elements of a vector is very important, because now and then we will be using some elements of the vectors, and not all of them. And in order to use some elements or a set of elements, we need to know how we can access them. We need to know how we can refer them, leaving the other elements out. And because of that, let's have another vector. Let's say we have a vector A, and this vector A is actually made up of the elements. Let's say A is made up of some elements. We can have as many elements as possible. Let's say 1, 2, 4, 2, 3, 4, 4. We have an element 4. We have another element 32. We have another element 33. We have another element 2. We have another element 4, like that. And that is my vector A. Say that when I say A, when I call the vector A, all the elements are printed out like that. So suppose I want to access the fifth element, and in this case the fifth element here is 3, because this is 1, 2, 3, 4, 5, and the fifth element is 3. So you realize I need the name of the vector, and the name of the vector is the vector A, and in a square bracket the position, that is 5. So you realize that will give me the vector 3. And what if I want the elements of the vector, that is from the fifth element to, let's say this is the fifth, the sixth, to the ninth element. I want from the fifth element to the ninth element. How am I going to do that? It is very simple. I'll have the name of the vector A. Then in the square bracket, I'll specify the positions of the elements that I want, but I will not list all of them. I'll specify the range, because also the range is consecutive in nature. So I'll say from the fifth element to the ninth element, like that, and that will list all the elements that are in the specified position. That is the fifth, the sixth, the seventh, the eighth, and the ninth element, like that. So what if I want the elements, all the elements in these vectors, except, and I want you to be very careful with this statement. I'm saying I want all the elements in this vector except the 8th element, the 9th element, and the 10th element. So if this is the 5th element here, okay, the 5th, the 6th, the 7th, the 8th, I don't want this, the 9th, and the 10th element, I don't want this, but the rest I want to use them somewhere. So it is simple. I'll say the vector A, that is the name, and then in giving the range now, I will have those elements that I don't want to include them. That is what we call the complement of a sequence of elements. That is the complement of a sequence of elements. So I'll have the concatenating function, but in this case it will be a complement function. So it will be the concatenating function of the position of the elements that I don't want to include in the subset of the vector that I want to extract. So I don't want the 8th, the 9th, and the 10th element, like that. And then I'll close the square bracket and realize these will print all except the 8th, the 9th, and the 10th element. These three, as you can see, they are not included. It is what we call a complement of a sequence of elements. A complement of a sequence of elements, and it will extract all the elements except those listed, in the complement function. So suppose I want to list all the elements that are greater than a certain value or less than a certain value. It is simple. Like I'll say my vector A, and in this A, list the elements that are actually greater than 12. List all the elements that are actually greater than 12. And you realize it's only 32 and 33 that is greater than 12. As well, I can say my vector A, and in this vector A, list all the elements that are actually less than, let's say less than 5, that are actually less than 5, and we'll be having these elements except these three. I think it's these only 2 that are actually greater than 5. So reference of vectors is very important. Reference of elements of vectors is very important, because now and then we will be using them. Again, the functions, don't forget the functions, that is finding the sum, the mean, the maximum, or let's have another set of a vector, and we can do 1 3 of the sum of the function, because they are many, so we are only going to do sum. So I have my vector y, and my vector y is made up of a number of elements, and because it is made up of a number of elements, I need to use the concatenating function. So let's say I have 41 as one of the elements, negative 50, the vector we had actually declared before, 70 and 90. So this is my vector, and I want to get the mean. The mean function, I'll have the mean function like that, and that will give me the mean. I'll have the function to obtain the sum. I'll go very fast, because you guys now are well versed with this function. The minimum value, actually we didn't consider this in our first list of functions that we were listing. We were actually trying to tackle. So this function will obtain the minimum from this set of elements, and you realize the minimum there is negative 50. Again, we can compute the maximum using the max function, that is the maximum of the vector y, and you realize the maximum is 100. Now, again, at times we want to sort. It is like arranging these elements of the vectors in a given order, be it in an increasing order or ascending order, or an increasing order, or at times we call it a descending order. So I'll have the sort function, and the sort function here is used to sort the elements of a vector, and you realize that the sort function has the name sort and the bracket there where we define our variable. So sort y, when we say sort y, by default it will arrange those elements in an increasing order. By default, when I say by default, I mean without specifying the order. It will arrange them in an increasing order. So realize it is arranging them in an increasing order. So what if I want to arrange them in an increasing order? I'll be having my sort function. So I'm sorting y, and now I need to tell that it should be in decreasing. So sort y, and I'll say decreasing equals true. Decreasing equals true. Decreasing equals true. And now these will list the element, will arrange the element in a decreasing order. In a decreasing order, as you can see, we are starting with 100. Very important, the sort function. We can also find the square root of the function. So the square root of a function, suppose we have our y to be equal to 16, and we want to get the square root of the function y. We will actually say square root. We will use this is the function to find the square root, like that. The name of the function is here, and this is the bracket. So we specify the variable we want to find its square root, and is y, and we realize the square root of y, and here y is defined as 16, is 4. So those are some of the functions that those are some of the basic functions that are used in R for statistical summaries and analysis. So having discussed that on vectors, now we can go ahead and start discussing matrices. And the first question is, how can we create a matrix in in R. How can we form a matrix in R? So I'll be having a comment here, and I say creating a matrix, creating a matrix. Of course, the software is R. So how am I going to do that? You realize in creating such a matrix, in creating matrix, we need to use the matrix function. So the matrix function takes this form. This is the matrix function, where the name of the function is the matrix, and the elements of the matrix will be listed in the bracket. So suppose, let's say I have a matrix A, and this matrix A is of order 3. That is, it has 3 rows and 3 columns. How am I going to declare that matrix? And that matrix A is having elements 1 to 9. And these elements are listed in column wise. That is, we have the element 1, 2, 3 in one column, then 4, 5, 6 in second column, 7, 8, 9 in the third column. How am I going to do that? I'll come and say the matrix A is equals to, then the matrix function, matrix, like that. I open the bracket to list the elements. But we realize because this matrix has more than one element, again I need to use the concatenating function. Don't forget about that. So I'll be having my concatenating function inside the matrix function, in the parenthesis or in the bracket of the matrix function. So I list all the elements, and we list the elements column wise. So that is 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, all the way to 9. Then after that, I need to state the order of the matrix. That is the rows followed by columns. So it is 3 rows and 3 columns. And with that, I would have created my matrix A. So that when I say matrix A, it will give me these 3 by 3 matrix. And because, as you can see, in the first column, I have the elements 1 to 3, second column 4 to 6, third column 1 to 9. So they are arranged column-wise. And it's very important to take note that the first column is denoted by comma 1, meaning there could be that element is in the first row, second row, or third row. So the columns are starting with a comma, giving room of specifying the row, or rather taking care of the rows. The same, the rows are ending with a comma, meaning there's supposed to be something else, and that something else there is actually the address of the column. So 1 comma could be in the first column, second, or third. And that is very important when it comes to accessing the elements of a matrix. Very important when it comes to accessing the elements of a matrix. So how do we extract the elements of a matrix? How do we extract the elements of a matrix? Hope you now know how we can form a matrix. You can try forming a 2 by 2 matrix, and you see how the output will be. So here I'll say extraction, extracting elements for matrix, extracting elements for a matrix. How are we extracting elements for matrix? Now, when we were extracting elements in vectors, we were actually stating the name of the vector followed by the position or the address of that vector of the element of that vector in a given set of elements of the vectors. But now here you realize we need to specify 2 things. We need to specify the row and the column of the matrix. We need to specify the row and the column of the matrix. So let's say, suppose I want the elements that are in the first column the first column here. And as you can see, the first column is denoted by a comma 1. So I'll simply say A, and I'll have a comma 1, and that is that this will imply the first column, and I'll be having this column matrix. Remember, when I was introducing vectors, I said that it is R is treating column vectors as row vectors, but it actually treats them as column vectors. So what if I want to get the elements in the second row? Again, I'll just need to have the name of the matrix and the column, that is the second column. Row, that is the second row. And how do you know that this is a row? Because the comma comes after the number of that particular row, and I'll be having these elements in the second row. So suppose I want to access the elements in the second row, third column, second row, third column. That is, I want to access only this element, that is 8, because it is only 8 in this matrix that is in the second row, third column. How am I going to do that? I will simply say, give the name of the matrix A, and the row which that element belongs, which is 2, then comma the column which is 3, and this will give me the desired element. So basically that is that you specify the row and the column, or if you only need a column row, you specify the column. If you need a row, you specify the row. So what if now I want to extract the elements that are in the first and second row, first and second row, but they are only in the first column. That is, I want this element and this element, because this element 1 is in the first row and this element 2 is in the second row, but both are in the second column. So it is very simple. I'll give the name of the matrix A, and I specify the rows, but you realize the row is changing because we have row 1 and row 2. So I'll simply say row 1, 2, row 2, comma, but the columns, both of the elements are in the first column. So I'll be having my 1 to represent the column, and this will give me these 2 elements. This element is in the first row, first column, second row, second column. Now, what if now I want the elements that are in the second row, but now in the first and second column, first and second column. That is, I want 2 and 5, because 2 and 5 are in the same row, that is the second row, but they are in different column, that is the first column and second column. I'll basically say I'm a vector A, and my vector A will have the elements in the second row, but these elements in the second row, one is in the first row and the other one is in the second. One is the first column and the other one is in the second column, and I'll be having these 2 elements, that is 2 and 5. Now, what if now I want to get the elements that are in the first row, the first row to the third row, and they are into the second row, second column and third column. That is, I only need these elements here. I only need these elements. I only need this matrix here. I only need this matrix here. That is 4, 5, 6, 7, 8, 9. So you realize in specifying the row, I'll say from row 1 to row 3, and the columns will be from column 2 to column 3. So I'll be having vector A, and from the first row to the third row, and the column will be from the second column to the third column, and that is the desired output. So basically, you just need to take note of the row and the column in which the elements. Now with that, we can go ahead and discuss the operation of matrices. How can we carry out various operations on vectors, on matrices rather? So operations on matrices, operation on matrices. How can we add two matrices? How can we subtract two matrices? How can we multiply two matrices? So I'll be having an example. Suppose I have two matrices, B and C. So let's say I have the matrix B, and this matrix B is of the elements 2 to 5. That is 2, 3, 4, 5, and it is a 2 by 2 matrix. So I'll be having, I need to create my matrix. So I will be using the matrix function like that, and because the elements are more than 1, I can decide to use the concatenating function. But you realize when the elements are consecutive in nature, we can decide not to use the concatenating function, but instead just state the range, the first element to the last element. So I can say 2 to 5, that is the elements, and I'll be having the order stated as 2 by 2. So this is a by 2 by 2 matrix, having the elements 2 to 5, and these elements will be arranged column wise, as you can see. So the same, this matrix here, because it is consecutive in nature, we could have stated the range, and we could have avoid using the concatenating function. So I have another matrix C because I need to carry out some operation. So I have another matrix C. So this is also a matrix of elements, and let's say these elements are now starting from 5 to 2, and it is of order 2 by 2. Remember that the matrix should be compatible for addition and subtraction, and also as well for multiplication. And we know in mathematics, for two matrices to be compatible for addition, then they must be of the same order. That is, the number of elements, the number of rows and columns should be equal. And in order for it to be, for them to be compatible for multiplication, then the number of columns in the first element must be equal to the number of rows of the same of the second element. And a 2 by 2 matrix here will be compatible for both addition, subtraction, and multiplication. So I want to add two matrices. So basically I use the addition sign. So it will be the 2 matrix B plus matrix C plus matrix C. Remember, R is case sensitive, so I have a small c and I get it wrong. So B plus C, and this is the desired matrix that is actually the sum of B plus C. And you realize the operation of addition of matrices obeys in R. That is, we are adding the corresponding elements. That is, 2 is added to 5, 3 is added to 4, and like that. Suppose I want to subtract, I'll be having B minus C, and my C is a lowercase and it is case sensitive. Remember that. You always need to remember that. So again, subtraction is as well as subtracting the corresponding elements of the two matrices. What about multiplication? Now you realize here in multiplication, if we take B and we multiply by C, the normal multiplication that we all know, you realize this answer here we obtain is actually a multiplication of the corresponding elements. That is, we are taking 2 multiplied by 5, getting 10, 3 multiplying by 12, getting 3 multiplying by 4, getting 12, 4 multiplied by 3, getting 12, and 5 multiplied by 2, getting 10. And this is actually wrong, because we know in order to multiply matrices, two matrices, then the rule is at any given time a row is multiplied by a column, then we sum up. A row is multiplied by a column, then we sum up. So for multiplication, this is what we will be having, that is b, the modular sign multiplied by another modular sign, like that, and these now will carry the normal multiplication of given two vectors. Very important to take note about this. This is the multiplication, but this one here is a wrong multiplication of vectors because it is multiplying them element wise. But now you realize here, for matrix B, if we have this row multiplied by this column, then we sum up. This is 2 multiplied by 5, that is 10. 4 multiplied by 4, 14. You sum up, you're getting 26. And 2 multiplying by 3, we are getting 6. 4 multiplying by 2, we are getting 8. 6 plus 8, we are getting 14. So this is what we should normally use when it comes to multiplication of matrices. Very important. Again, just like in vectors, where we were having other functions that carry some basic operations, we also have a number of functions that carries or rather carry out basic operations of matrices, such as, suppose we want to get the determinant of the matrix, and you realize to get the determinant of the matrix, we use the determinant function, and the determinant function is denoted as det, like that. And this is the name of the function, and we have the matrix in the square bracket. In the bracket. So for this case, my matrix is B. So what is the determinant of B? And realize the determinant of the matrix B is actually -2. Suppose I want to get the transpose of the matrix B. I'll use the transpose function, that is T, and then the matrix in the bracket. So the matrix B, the transpose of the matrix B, and realize that this is the transpose of the matrix B. When I want to get the inverse, how do I get the inverse? I use the function. The function for inverse is solve. The name of the function is solve, and we'll be having the parameter, or rather the matrix in this case, in the bracket. So matrix B, solve for B, will give us the inverse of the matrix B. As you can see now, the inverse of the matrix B is actually this matrix here. You can try that on free time and try to calculate and see if this is the correct answer. But actually, indeed, it is. So suppose I want to get the diagonal elements of the matrix B, the diagonal elements. I'll use the diagonal function. So I'll say diagonal diag of B, that is the function, and you realize the diagonal elements are listed as 2 and 5. The diagonal elements are listed as 2 and 5. Well, at times we need the sum of the diagonal elements. And what do we call the sum of the diagonal elements? The sum of diagonal elements of a vector is known as the trace. So I'll simply use the sum function. Inside the sum function, I'll be having the parameter as the diagonal function. In all, the diagonal function will determine the diagonal elements of the vector, and the sum function will sum those elements. So the sum function, then we need to determine the diagonal elements. So I'll be having dag B, matrix B, and this will give me the sum of the diagonal elements, which is the trace. As you can see, this is one will determine the diagonal matrix, the diagonal elements, and the sum function will sum the elements. Suppose I want to know what is the dimension of the matrix, or rather the order of the matrix, so I'll simply use the dimension function, which is dim, like that, and I specify the matrix as B, and this will give me the order of the matrix B. And yes, of course, the order of the matrix B is a 2 by 2 matrix. Now, at time So at times I have two matrices and I want to bind them together. Let's say I have the matrix A and the matrix B. I want to bind them column-wise, or I want to bind them row-wise. So when we want to bind them column-wise, I'll say C, specifying that I want to bind them column-wise, then bind the matrix B to the matrix C column-wise. So you realize this is here, this is our matrix B, and the matrix C is binded to the matrix B column-wise. That is, we have the columns of the matrix B, and then the columns of the matrix C will follow. What if I want to bind them row-wise? I'll simply say R bind, and you realize this matrix here will come and bind row-wise. That is, after these two rows, I'll be having this row down here and the other row down here, and that is it. So we can bind the matrix like that. Suppose I want to form an identity matrix. And we know basically an identity matrix is a matrix that has one elements, one in the leading diagonal or in the main diagonal, and zeros elsewhere. So I need to specify the order of the matrix if it's a 2 by 2 identity matrix or such. But because the key thing is about the diagonal elements, the name of the function to form the identity matrix is actually DAG, and we specify the order. Suppose it's a 3 by 3 matrix, and we'll be having our identity matrix, and we realize in the diagonal elements we are having 1, and this is an identity matrix. So those are some of basic operations that can be conducted in R. There are many more. You can do your research and get to understand even better. With that, we will go and discuss about matrix factorization. So I'm having a comment, matrix factorization, matrix factorization, matrix factorization. Now, matrix factorization generally is dealt in mostly in linear algebra and in mathematics, and several matrix factorization are possible using the current version of R software. With other possible factorization can be carried out by installing the appropriate packages. As you can see here, the packages. We learn about packages. This is just the introductory part, but as we continue, we will get to know more about the packages and many more functions and operations that we can conduct using R. Actually, R is very wide. This is just but the basics of R. Now, we realize here we will do what we call eigen decomposition, and this eigen decomposition in most of cases is very handy in linear algebra, because that is saying we'll do what we call the eigen decomposition, decomposition like that. And of course, there are other forms of decomposition that we will not consider, but there are many more, and we'll get to learn them as we continue. So if we want to get the eigenvalues and eigenvectors of a given matrix, we will use the eigen function. That is the eigen function, and the eigen function will take that form, and this command will extract both the eigenvalues and the eigenvectors of a given matrix. The eigen function will basically will print out the eigenvalues and eigenvectors of a given matrix. So let's have an example. Actually, we didn't specify the matrix here. That is why is saying we could not find the function eigen. We could not find the function eigen, but we will apply it even as immediately after this example. So suppose I have a matrix A, and say A is the matrix. Say A is the matrix, and the matrix A is having the elements from 1 to 9, and this matrix is of order 3 by 3, is of order 3 by 3. So that is my matrix A. Say that when I call A is that matrix, and I want to get the eigenvalues, or rather the eigenvectors. I want to get the eigenvalues and eigenvectors. I will simply say eigen of A, and this will bring out the eigenvalues like this, and the eigenvectors like that. Those who are doing linear algebra are well versed with the eigenvalues and eigenvectors like that. Now, suppose at times I want to separate them. So if I want to separate them, then I need to assign a name to the eigenvalues and eigenvectors. I assign a name to the eigenvalues and eigenvectors. Suppose I call this eigen in short form like that, and I say the eigen is equals to, actually eigen is equals to the eigen values of the matrix A. So these are variable eigen will store the eigenvalues and eigenvectors of this matrix A. After they have been obtained by this function, they are stored in this memory named as eigen, that is the variable eigen. So that when we say eigen, it will print out the eigenvalues and eigenvectors. And what if I want to only obtain the values and not the vectors? And what if, and the same, what if I only need the vectors and not the values? What am I going to do? What am I supposed to do? This is possible when we have assigned the name to the eigenvalues and eigenvector. And that is why we were actually saying it is very important to have variables, because without a variable here, we could not be able to separate the eigenvalues and eigenvectors. But because I have the eigenvalues and eigenvectors stored in the variable eigen here, in this short form, I'll come and say eigen, but I only need the values. So I'll be having the $sign and the word values like that, and this will give me the eigenvalues without printing the eigenvectors. The same, if I need the eigenvectors, I'll have the variable which has been assigned the eigenvalues and eigenvectors, and the $sign, and then I'll say vectors, and these will give me the eigenvectors without printing the eigenvalues. That is some of the decomposition of matrices that we will consider in this tutorial. So basically, up to this juncture, you should have understand how we can declare a variable and assign a value to a variable, how we can actually use the variable to perform certain operations such as addition, subtraction, and all that. You must also be able to declare a vector, how we can declare a vector and have all the elements of that particular vector, and how we can carry out different operations such as the sum of the vectors, multiplication and division of the vectors, the maximum, the minimum, the variance, how to sort the vectors and all that. And the same, at this juncture, I'm expecting you to know how to create a matrix. Having created the matrix, how you can carry out different operations of matrices such as addition, subtraction, multiplication, and be very careful with the multiplication. Remember that we are not using the asterisk, but we are using modulus, steric modulus, to denote the normal multiplication of matrices as required in mathematics, you must also be able to carry out different operations in matrices, such as finding the determinant, the transpose, the trace, the inverse, the dimension, creating a diagonal matrix, binding of matrix, row-wise and column-wise, matrix factorization, what we have just discussed, that is the eigenvalues and eigenvectors. So with that, we are done with the introductory part of R programming, and basically, like I was saying, R is a free software. You can easily download it and install it and start using it, and it is very easy to master the commands of R and be able to do some statistical analysis using R. And here we are presenting the concept, the same concept, but in a more simplified version that anyone can understand. You don't have to be a programmer, you don't have to be a statistician, you can just master the concept without even difficulties here and there. And yes, of course, these will be helpful when it comes to computation and such. So in the next tutorial, we will discuss how we can do statistical graphics in R. That is how we can generate graphs, such as performing simple plots like histogram, like scatter plots, like pie charts, box plot, the contour and all that. So we will discuss about the statistical graphics using the R software. So go through the set of questions. Actually, I have a set of questions that you will consider in your practice, that is on vectors and as well as on matrices. You can go on try to tackle those questions or exercises, and if you feel like you are facing a challenge, you're having a rough time, you can simply comment down there and we will consider how we can assist each other. In the meantime, if this is the first time to watch our tutorials, don't forget to subscribe. Click the notification button such that when the next tutorial is available, you are notified. And don't forget to share, because actually we are planning to have the next session, that is on statistical graphics, live. That is we will be live and people will be able to comment as we continue, and to make sure that we try to answer their questions at real time. That is, we are answering the questions, the doubts, we are clarifying as we continue. And if there is a point that you don't understand, you will be able to say, can we kindly repeat that, so as we can comprehend everything. Otherwise, let's continue to subscribe, let's continue to comment. If you feel like there is any topic that we need to discuss, don't hesitate to comment. Let's share the link to other friends so that we can have a good number and we will be able to learn one or two things. I'm your host today, Mr. Mtulu. I know majority of friends out here like to call me Professor Mtulu. It's okay and awesome. Let's meet next time for statistical graphics. All the best.